Hi everyone, welcome to my basic fire tutorial series. Now we are in the module 2, HTTP interaction and searching. This tutorial series was created for the master program in data science for healthcare and clinical informatics at the Faculty of Medicine, Ramatibadi Hospital. So let's begin. My name is Ratpanyawat and you can contact me in this channel. In module 2, there will be 3 parts. In the first part, that is this video, I will talk about file server. And then in the next video, I will talk about HTTP interaction. And the last one is searching. So file server. Before we begin, if you are interested in this topic, I recommend you to watch this video. It's a video from Mr. Christian. Sorry, I'm not sure how to pronounce his surname. I think Knap. Yeah, it's about integrating a file server in your architecture. It's very good video, and I draw many things in this lecture from his video. So if you want to watch the original one, you can watch this clip. Okay. So file server. File server is any software that implement the file APIs and use file resource to exchange data. This definition comes from this page. It's an architecture overview here. You can go here, getting started, and see architecture overview. And in this page, in the somewhere below, there will be a definition of a file server. This one. So, and the definition of what is file API and file resource. But in summary, is software that implement the file API and use file resource. As you will see that this definition is quite broad. So technically, any server that can return a capability statement resource could be considered as file server, because capability statement is a resource to describe what that file server can do. So if that server can return a capability statement, even though they cannot do anything else, then it's considered a file server. There are mainly 2 types of a file server, a generic server and a specific server, or you can call it facade. There is another type of server, that is a terminology server, but I think it's a little bit out of scope of this lecture. So for now, we will focus only two types of this server. And there is a lot of file server vendor. The most famous one for education and some production is Happify. You can go to here. This link is happify.io. This one is an open source implementation of file server and also client. So we will start with generic file server. Generic file server is server that mainly support all interactions and all standard resources in file, and generally it includes data storage of their own, like this one. And there are several vendor and open source projects provide this kind of server. You can install on your own infrastructure, or some vendor provide it as a cloud solution, cloud platform solution, platform as a service. We can show it in a picture as this. Suppose we have a source system and we have a file client installed on that. A generic file server is a server, an application that have a storage of their own, an internal storage. And here on the right side is a consumer system. Let's say that they have a file client as well. When these 2 systems want to exchange information, the source system will have a file client retrieve the data from the database, from the source system database, and then convert it, translate it into a file resource, and put that resource to store in the database of a generic file server. The key concept is that it has two copy of data from here and copy to here in a file data model. And then when the consumer want to get that data, they make a file request, and this respond with a file resource back to a consumer system. So they are communicate with a middleman. This guy is a middleman. So this is the pro and con of a generic file server. I think I would start with the cons first because it's easier to explain. As you have seen before, that the way it works is that we have a file client retrieve the data and convert it to a file resource and then send it to the server. So usually it's not a real-time data because there is some delay between each retrieve and then convert and then send to the server. Let's say that we pull the data every hour, every 15 minutes, or every day. Then there is still some lagging. It's not a real time. So that is the problem. It's not a real time data, and normally it's quite one directional. That is the client pull from here and then push the data to here. So suppose we have another system that want to send the data here. They have to send here to the server in the middle first, and then this server have to have additional capability to convert that request and post it to the source system, or the source system must have a way to periodically retrieve the data from this file server. So it's a little bit more complicated, but the main idea is that generally it's one-way direction. The source system retrieve the data and convert it to file resource and send to the server. And another problem is when you do it this way, there are two data storage. This increases the security and privacy risk because you have two locations that the attacker can attack. And moreover, because it has two locations, sometimes it's difficult to maintain the integrity between these two locations. Maybe the data is different between the two locations and you have to have a way to manage it. So that is the problem with generic file server. But the pro is that it's easier to implement compared to another one or the facade. I will show you later because you just put the server here and then have another application here to pull the data and then send to the server. You don't need to convert every request and convert every response. That is a lot more complicated in my opinion. Moreover, I think it's more reliable because this system retrieve the data and send to the server every specific time. So let's say once an hour. So the chance to have an error is once an hour. It's not like a facade that send and translate every request. And in that case, there may be a higher chance of error. And because it doesn't have a real-time data, so it's suitable for a system that doesn't require it, like a reporting system. You pull the data here, send to a server, and then someone retrieve the data to build a report. So that is a generic file server. The next type of server is specific file server, or you can call it a facade. Is usually implement only some parts of the API or for specific use case. This type of server usually connect to the existing systems as backend, such as a backend of an EHR. So the server doesn't have to have a data storage. For example, let's say that we have an existing EHR, but we want to accept the file API in the appointment module. So we have a facade for that module, or adding a lab report API to an LIS so that other system can get the lab result in a file resource format. Okay. There are mainly two ways that we can implement a facade. The first one is we put a facade on the source system, and the second one is we put it on the consumer system. First, if we put the facade on the source system, when the consumer system that has the Fire client want to retrieve the data from the source system, the consumer system make a Fire request because it has a Fire client. It make a request to a facade, and the facade convert that request into a native request. Maybe that the system has a database like MySQL, for example. This will be the SQL query to the MySQL database. And then when you query the database, you get the response, the return a data from the database, a native response to a facade. A facade will convert that response into a file resource and then send it back to the consumer. So this is how it works if you put the facade on the source system. If you put a facade at the consumer system, the one who initiate the transmission will be the source system. The source system will have a Fire client installed, and the Fire client will retrieve the data from the database and convert it to a file resource to a facade here, and that facade will convert that resource into a native data that the consumer system can understand. So this is how it works for the facade. And this is the pro and con of the facade. I will talk about the con first. The facade is more difficult to implement because as you can see from this picture, they have to convert every request from the consumer to be a native request and convert every response from the source system to be a file resource. So it's more difficult to do so comparing to the generic file server that you just pull the data once and then send it to the server and as the whole transaction. And that is the cons. But about the pro, because it's convert in real time like this, so it's usually real-time data and it can be bidirectional communication. For example, let's say that this consumer system want the data from here. It can make a request through here to here and then get the data in this direction. But it can also send the data from this system through here and then go to here in this direction as well. So this is what I mean by two-way direction if you want to support that feature. Like I mentioned earlier in the generic file server, if you want to send the data to this source system, you will have to add the functionality to the server or make this system retrieve the data from here periodically. That is make it more complicated. But in facade, if you choose this way, you can make it bidirectional information flow. But this one is another story. I mainly mean this one. The second benefit is, as you can see, there is only single data storage. You don't need to maintain multiple data storage like in generic file server. So the security and privacy risk is below the generic file server. And because it's pretty real time, so it can be used in the workflow of the clinical settings. Like maybe you use it for telemonitoring or some other way that is real-time connection. And another benefit is that many EHR vendor in the market might already have the built-in facade for you, so you don't have to implement that. but it's not in Thailand right now. From what I know, there is no HR vendor that support a fire functionality for now. And you even can combine generic file server and facade in the architecture if you want. Let's say that you have a facade on the source system and also have a generic file server somewhere else so that you can communicate all track with fire. So I will give you some example architecture. Let's say that you want to connect the file server to an EHR of your hospital. In this area, the box one is a network that you are in control. Maybe it's internal network or maybe it's the exchange zone that you plan to exchange with other parties. And here is the external network that is not belong to you. So you have two options. The first one is facade and another one is generic file server. Let me remind you, facade has no data storage and generic file server has a data storage here, this one. So if you want to communicate with external network, let's say other people make a file HTTP request here to a facade convert that request into a native request that your EHR server or HAS understand. That server return a native response to a facade, and then that facade convert it to a file resource and return to the requester. But on the other hand, if you want to use a generic file server, you have to have a file client installed maybe in your internal network to get the data from the EHR server or database and then convert it to a file resource and send it to us to store it again in the generic file server. And then when the external party want to retrieve the data here, they retrieve it from here. The request sent to here and then get the response as a resource back immediately. No need to go through all the way to here. But in the facade way, the request go here and then the facade translate it all the way to here and go back here and then go back here. But for this one, just go here and go back. And there are another one who constantly pull the data from here to store here. So that is how it works in case you want to have a file server to an EHR. Another case is external data reporting. Let's say that you are working for a hospital and there's other hospital as well, and you have a government that you have to periodically send the data to them. So option one is you install a server or a facade, anything in every hospital to connect with the source system, and then the government is the one who make a request to a file server and get the file response back to its system. In this approach, so every hospital need to have a file server like this so that the government can make a request to each hospital's server. But maybe not all hospital has a capability to maintain a file server of their own. And moreover, some hospital might don't want other people to query inside their network or to query whenever that person wants. So they want to have more control over their data. So in this case, another option that might be better is putting a server on the government side and install the file client in each hospital. So when the hospital want to send the information, they can use the client to retrieve the data, convert it to a file resource, and send it to a server. This server can be generic or facade, it doesn't matter, but it's on the government side. In this approach, we only need one file server at the center, and the hospital have more control over its data They can choose which data they want to send and when they want to send it. So that is the case for external data reporting. The next example is Clinical Data Repository or CDR. CDR is like a data warehouse in many ways that it extract the data from many source system, but it's mainly for storing clinical data into its data storage, and then other system can retrieve the data from the CDR. To allow other system to retrieve the data that is inside this CDR in a standard format, maybe it's a good way to put a facade here in front of the CDR, and when the consumer system want to retrieve the data here, they can request it in a file format, and then the facade convert that request, retrieve the data from the CDR, and then send it back to the system, same as the system B. And if we have more and more consumer, maybe it's even a mobile application that want to get the data from this central repository, they can send it as a file request, and this facade will convert the request, get the data, and send the resource back in file in a standard format. So this is in case of the clinical data repository. And in case of system integration, let's say that we are in a hospital or some kind of networks. In this case, every system, A, B, C, D, all of them are both source and consumer. They are source for other system, but they are also consumer of other system. So option 1, if we put the generic file server here, this one will act like a middleman, and every system will communicate with this server. So the problem of this approach is the data is not real time, and the server here, they need to maintain the data integrity between multiple sources, but this may be a good approach in some situation. Like we have a lot of systems that we have to integrate, maybe hundreds of systems, then this approach might be better. If we don't use a generic file server for this problem, we can have another approach, that is, we can install a facade on every system, and then everyone can communicate directly with each other. The good thing of this approach is now everyone can get the real-time data, but the problem is it's more difficult to maintain the integrity between data because there is no single system whose responsibility is to maintain the integrity like in this one. So this approach may be possible if the number of the system is not so high, but if it's like 100 of system, then this one may be better options. So that it is for example architecture. The last section of this lecture, I will guide you for some open source and commercial file server. For the open source file server, the main one that people use a lot is HappyFire. You can go here, this one HappyFire, and you can go to documentation. Happy server come with many things. There are client, there are plain server, GPA server. Typically, when people want to install a HappyFire for practice or for education, they mainly use a JPA server. You get started, it will redirect you to GitHub, and you following this instruction. So that is HappyFire, and there is another one as well. I think FileTeam, there is also another file solution vendor. They have provide a lot of tools for the community, both free and commercial. Spark is a reference information in .NET that they provide to the community. Firebase is a file server implemented on PostgreSQL, and Asymmetric is on Node.js. And there are also several open source file servers from the cloud provider as well. These are the file servers that has been customized to more compatible with each cloud provider. Like in Azure, they will have some Azure Storage, Azure Identity Manager to manage that file server. For commercial generic file server, there are a lot of provider here. Smile CDR is from James Agnew, the same owner of Happy Fire. Filey server, the previous name is Vong Fire server. They are from the Filey team that mainly develop Fire solution on .NET. And Google Cloud Healthcare Azure API for Fire. This tool is like a platform as a service that you pay for the API, but you don't have to maintain the infrastructure. You don't have to install the program on your server. And there are other providers as well. I think every company might have some strength and weakness, but I never explore them deeply as well. So if you know something interesting, please feel free to share it to me. And so if you want to practice Fire with the Happy Fire server in your local machine, I think it's easier to install Happy Fire server as a generic file server or a server with data storage. Go to here and follow the instruction here. The easiest way is that you use a Docker, like Docker pull and Docker run and then finish. But if you cannot use Docker, you have to do it manually here. So using Maven Jetty run, but before you can do that, you have to have Java and Maven install first. And there's a lot of manual on how to do that on the internet. That it is how to set up Happy Fire locally. But if you want to have a server for other people to use, like the one that I share with you in the class, you have to build it and deploy it first. You can following the instruction here. Maven clean install or deploy it with Docker Compose, this one. And when you have successfully run the server on your local machine or on the internet, if you go to the home page, the localhost 8080, it will show you this page, the web UI page. But the Firebase for interaction with the Fire API will be this location. Alright, so that it is for today's lecture. So if anyone has any question, feel free to ask me in this video or ask me on the next Wednesday that we meet. Okay. Thank you very much for attending. Bye bye.